Hey everybody, welcome to Partitioning Rectangles. Partitioning Rectangles is actually really cool. It starts off with the area ideas that we learned earlier in the school year, and we kind of extend that and we use what we learned about area to help us with multi-digit multiplication. It's kind of cool. Let me show you how it works. Okay, so we started off with the kids and we talk about, let's go back to looking at our area. So let's say I just draw something that looks like this. Do an area of this rectangle. So this is a 3 units, 1, 2, 3, 4, 5, a 3 by 5 unit. We say, okay, how do we find out the area? How do we figure out how many squares are inside this thing? Well, we use our area equals length times width formula. Our length or our width, 3 times 5. That's going to give us 15. It tells us there are 15 square units inside here. And that's a pretty basic one. That's one of our original math facts. But we can take this idea and we can extend it to working with larger numbers. So we start off with a small number so the kids can see how it works. Let me build one for you. How about we do let's go with a 4 by, let's see, get as big as we can here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go with a 4 by 13. Because now 4 by 13 is not a math fact. We haven't done 4 times 13. That's not one that you just memorize. So let's complete our rectangle. So this is 4, and to start off when we do partitioning rectangles, I have them write the 13 down below, and you're going to see why in a minute. So it's 4 by 13. So instead of saying, well, what's 4 times 13, because maybe some kids can't do 4 times 13. That's not one that you just memorize. We go, well, let's break it into its pieces. Let's break it into its tenths, or I'm sorry, its tens and its ones. So let's go here, we've got 1/10, so we've got 10 squares. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll cut it right here. We're going to break it into 2 parts, the tens place and the ones place. So this size piece right here is a 4 by 10, and this little guy here is a 3. Which makes sense. It should be that way because 10 plus 3 equals 13. That's why we put that down there. So we make sure whatever we have up here needs to add up to what we have down here. Well, now we can do 2 math facts. And we've worked with extended math facts, so that's really all we're doing with our tens place is an extended math fact. A 4 times 10 is going to be 40. 4 times 3 is going to be 12. So inside here we have 40 squares. Over here we have 12 squares. Well, if we want to know how many total squares there are, all we do is put them together. 40 plus 12. And you get 52. So that's one way to do partitioning. Let's go a step further here. Because it's really easy to see, and I tell the kids it'd be awesome if you just carried around a piece of grid paper with you all the time. It's real easy to do math that way. But that's really not how the real world works. So let's try doing one of these problems without the grid squares to count. Because we can always count the grid squares and make sure that we're correct. What if we don't have the grid squares? Then we have to just trust the math. So let's go to a blank piece of paper. So I'm going to give the kids another problem, and let's get real crazy here. Let's go with something like 87 times 9. Now that's a big one we wouldn't be able to do at the beginning of the school year. That's a pretty big math problem. Partitioning rectangles, this is our intro into being able to do problems like that. So we're making a rectangle. Let's make one. I get the cheat, use my board. Draw a rectangle. And now let's write our math facts down. So we're going to put our 9 on the side, and like I said, we're going to put that 87 down below so we can break it into pieces. Now, I know that the 7 is going to be a heck of a lot smaller than 80, but I'm really not concerned with making sure that they're accurate cuts up top. I'm going to cut it right here. This is going to be 80, and this is going to be 7. Now I know that this is a lot wider than what 7 would actually be, but it's a little bit smaller than 80, and that's all I really want to show right now, is that I know 80 is bigger, 7's smaller. Now I got to do my 2 math facts. Well, this is an extended math fact. 9 times 8 is 72, with an extra 0 at the end. 9 times 7 is 63. And if I want to know how many total squares, well, there's 720 squares inside here. There's 63 squares inside here. Total. $783 square units. So if I was doing that math problem, 87 times 9, the answer is 783. Pretty cool. Let me show you one last problem, because I want to show you a little trick that we talked about with the students today. Now, I really want them to concentrate on just cutting it into the tens place and the ones place, but I show them that you can do this a bunch of different ways. Let's take a look at that problem that we did before. I believe it was 13 times 4, if I'm correct. 13 times 4. The first way that we cut it, we did 10 and 3, and 40 and 12, 40 and 12 was 52, okay? But we talked in class, and let's say I don't feel comfortable with my extended math facts. I don't feel comfortable doing 4 times 10, or 5 times 200, or 3 times 4,000. I don't feel comfortable with all these extra zeros. Well, you don't have to. Let's take this, and I'm going to break it into 3 parts. 1, 2, and I'm going to say, instead of 10, I'm going to break this into 2 5s, because 2 5s is the same thing as 10. And then I'm going to have still that group down there that's a 3. Well, let's look here. 4 times 5 is 20. 4 times 5 is 20. 4 times 3 is 12. And if I put all those pieces together, 20 plus 20 is 40. 40 plus 12 is 52. So as long as this pile of numbers up here still adds up to 13, I could do any combination of numbers. And if you have a student that really likes to challenge themselves, I was telling some of the kids, try different combinations. It's just kind of a fun math game that would make 13, and keeps trying to see if you're going to keep getting that same answer of 52. If you do it correctly, you should keep hitting that same answer. So partitioning rectangles is a nice intro before we get into partial products. And after we have a firm understanding of partitioning rectangles and partial products, and we understand how multiplication works, then we move into traditional multiplication, so the kids get the real quick algorithm. They'll be able to work through these problems really quickly. And that's partitioning rectangles.